Hey Jesse, how you doing? I see that you have many trigonometry questions, and I already answered one for you. This is the second one, and I do it also by video, just because it's much easier to show graphics uh, using that platform that we have on Wyzant. So anyway, here you've got a balloon. We'll call that balloon right here, point B. It's above the mole. So the balloon is above the mole. And Mr. Helmut here, I'll call him point H, sees the balloon due north, which is, I'll just consider this to be north, and just consider this to be south. Due north, he sees the balloon at an angle of 49 degrees. So this angle here is 49 degrees. Okay, from Mr. Helmut's side. And Ellis, we'll call this E, Ellis, sees the balloon due south at 64 degrees. So this is 64 degrees. Not 64 degrees. And the question is, what is the distance between Ellis and the balloon? So he's looking for this hypotenuse distance here. This is the distance he's looking to find. Okay. So we're going to have to use trigonometry and some geometry in order to solve this, but it's not that hard. First of all, we also given that the distance between Ellis and Helmut, that distance here, is 500 meters. 500 meters. That's all we have in terms of what's given, and we have to solve for that length BC. I'm going to call this, since this is a mole, I'll call this point M. So in order to illustrate my solution here. So you've got this situation, and we need to solve for this BE, which is the hypotenuse of triangle BME. So triangle BME. Triangle BME. So looking at this triangle BME, we have an angle here, interior angle, and we have, this is 90 degrees because that's a straight distance. So this is a perpendicular line that from the balloon to the mole. Okay, and so therefore we know that this angle is 90 degrees. So this is 90 degrees, and therefore in a triangle BME, the sum of all the angles in the triangle should be 180. Therefore, this angle here, which is angle MBE, and I do this as an angle, and this means that this is the angle at B for triangle MBE. If it was the different one, let's say the angle was at E, it will be MEB, but this is MBE, and the angle right there is equal to 180 degrees minus 64 degrees minus 90. So this angle will be 26 degrees. And so this angle here is 26 degrees. Okay? And so we also know in triangle HBM, triangle HBM, that the angle HBM and I also put that right above B because that's a vertex, is equal to 180 degrees minus 49 degrees minus 90. So that comes to 41 degrees. So it comes to 41 degrees. Okay. So we identified all the angles in all the triangles. But we have a problem. We do not have any length of these legs. Like say for triangle BME, we do not have ME or MB. And for triangle HBM, we do not have HB or BM. But we have the angles. The angles alone isn't going to be enough for us to solve it by trigonometry. We're going to have to use some other method. Well, the other method is we take the entire triangle, and I'm going to draw this in magenta so you would see triangle HPE, the whole thing. So what do we know about this triangle? Well, we know that this angle here is the sum of 41 and 26. Okay? We know this angle is 49. We know this angle is 64. And we know that length HE is 500 meters. Can we use something different here in order to solve for this? Well, what's common in both triangles BME and HBM is this altitude here, which is BM. And that's common for both triangles. So if we can find this, we can also, which is going to be good to find this length HM. It's also going to be good to find this length ME and or the length BE, which is we're after. Okay, so if we take triangle, I'm changing the color here now. I'm going to take triangle, go back to black. If I take triangle HBE, so triangle HBE, and we want to find, well, we already know what the angle at HBE is. So angle HBE that angle here at B is equal to 41 plus 26. 41 degrees plus 26. And that gives us 67 degrees. 67 degrees. Correct this a little bit better. Okay, 67 degrees. So how can we find, for example, this hypotenuse here? Or how do we find this leg here? Well, we cannot find this leg, but we can find this hypotenuse for this triangle. This hypotenuse can be found by the law of sines. So we know that what HE is. So it will be, the law of sines will be the leg divided by the opposite of angle equal to the leg divided by the opposite sine of the angle. So sine of the opposite angle. So will be 500 meter divided by, what is the opposite of angle of this 500 meter? It's this one here on the vertex B, which is 67 degrees. So that's sine 67, law of sines, equals HB, which is this hypotenuse, divided by sine of this angle here, 64. Implies that, let's do some calculation. HB is going to be 500 sine 64 over sine 67. And I already done this calculation, and HB is going to be 488.2 meters. .2 meters. So we found this HB to be 488.2 meters. I'll write it down here. 488. Bear with me here, the pen isn't very accurate. Okay, so this is that length here, HB of this triangle HBE. So now if we look at triangle HBM, we can see that we have a hypotenuse value. So if we want to find this here, if we take the sine of 49, we will get the altitude BM divided by the hypotenuse, which is 488.2. So if we find, so it will be sine 49, sine of an angle is equal to opposite over hypotenuse. So the opposite is BM. That's what we're after in the beginning. BM divided by 488.2. And BM is equal to 368.44 meters. 368.44 meters. So we found this length to be HBM 368.4 meters. I'll write it down here. 368. .44 meter. There isn't much space to do that. Anyway, so now in triangle BME, we have the value of BM. of BM, which is 368.44, and we have the angle here of 64 degrees. So how do we find the hypotenuse? BE, which is the distance between Ellis and the balloon. Well, same thing, sine of 64 degrees. So this will be here. Let me write down here, sine of 64 degrees equal to opposite, which is 368.44 meters, divided by the hypotenuse BE. That's what we need. So BE, if we rearrange this, BE is going to equal to 368.4 meters divided by sine 64. If you calculate this, the answer is going to be 409.94 meters. And this is your final answer for BE. Like I said before, if you like what you see, contact me on Wyzant and to set up lessons for other problems. Now, take care.